This meeting is being recorded.
Hi, welcome to this Open Security Summit in March 2022. We have Kim, who is going to, all the way from New Zealand, give us a really cool presentation about the OWASP PurpleTeam project, which is one of those projects that I don't think has enough exposure and needs to be a lot better known because it's a pretty cool piece of technology. And Kim is going to walk us through the evolution and how he achieved a really great integration about all these different tools, which I'm actually looking forward to see how it all fits together. Over to you, Kim.
Hey, cheers. Yeah, so we're just going to be running through today OWASP PurpleTeam, the local and the cloud environments. I recently, well, actually, I'm in the process of donating the cloud environment as well to OWASP. But I'll basically I'll walk you through all of that now. So PurpleTeam is a security regression testing CLI that's the front end and a SaaS backend. Targeting web applications and APIs, specifically built for developers. The CLI is specifically targeted at sitting within your build pipelines. It can be run headless, and it can also be run manually with a character user interface. You can choose from either local and or cloud environments. If you choose local, you need to set up both front end, that's the CLI, and back end microservices. If you choose cloud, all you need to do is get the CLI on your system that you want to run it from, configure that, and create a job file. So the journey so far to bring PurpleTeam from proof of concept to where it is now has been a little over 4 years. I finished writing a book series to help developers upskill their security, and ran a whole bunch of workshops with a proof of concept to elicit developer feedback and confirm that what I wrote about was actually true. Most of the time it's been like 7 days a week, 2 full-time jobs. So I donated PurpleTeam local to OWASP in Q1 of 2021. And PurpleTeam Cloud went to market in Q4 of 2021. I couldn't get the publicity that was needed to get enough customers on board to make the cloud financially viable, plus family relationships were getting strained. So I'm in the process now of donating the cloud environment to OWASP. So now the community gets to reap the benefits of a production-ready, hosted security regression testing software as a service that you can plug into your build pipelines to continuously test your web apps and APIs. Building a tool that helps developers write secure code is a great way to learn about security. If you want to learn more about information security, we can help you by assigning you a mentor, and you can help yourself and the community by building PurpleTeam with us. So I'm going to run you through a high-level architecture overview of what PurpleTeam looks like. So this is the cloud environment, and this is the local environment. I'm going to basically walk you through the local environment. There's slightly fewer components in it, just due to sort of like authentication. As you'll see there, you've got the API gateway and a network load balancer in front of all the other components. All components are in AWS, other than some DNS. Okay, so with the local environment, we've got the CLI, which sits in your build pipeline, or you can run it manually, as I mentioned. You've got your system under test up here, which is your web application or an API. You've got the internet there, and you've got all your back-end components that are sitting on a machine somewhere of your choosing if you're running in the local environment. So you've got the orchestrator here, which is your first basically point of contact for the CLI. So what happens is the CLI sends a job file through to the orchestrator. Once you've configured the CLI and have created a job file which specifies what you want to test, so like the URL, ports, different routes that you might want to test. There's quite a bit of stuff you can add in there, but generally you want to start off really simple and just get things up and running. Like you can rule out false positives and there's all sorts of configuration options, and that's all on the documentation as well. So we've got two main ways of communicating here once the test run is actually up and running. So you've got initial test command, which goes through to the orchestrator. And then once the testers are up and running and the emissaries are running, the emissaries are what actually do the testing work. Then what happens is the testers send back to the orchestrator in real time basically what's happening with themselves and the emissaries. So you get real-time feedback as to the defects that are being found and basically how the whole system's progressing. So those messages get put into Redis lists and then pushed straight to the orchestrator. If you're using long polling, which is what we use in the cloud due to the AWS API gateway limitations, what happens is Orchestrator receives those messages from Redis, and then it pushes them back into another Redis list. And then as the long poll requests come through to the orchestrator, it pops those messages off the list and sends them back to the CLI. In the local environment, you can use server-sent events, which means that as a tester progress messages come through into the orchestrator, they just get pushed straight back to the CLI. So everything's just completely non-blocking and just flowing all one way back to the CLI. In the local environment, we use SAM CLI to host some Lambda functions. The Lambda functions are responsible for bringing up the applications scanner emissaries. So these are a couple of container sets. So we've got Zap running there and we've got Selenium running there. They go hand in hand. Now the number of these emissary sets that get brought up per test run is based on how many it's based on basically what is in the job file. It's based on how many test sessions the build user decides to put into the job file. We've got a soft limit at the moment of 12 test sessions. Generally, you don't need anywhere near that many. So, for example, if you've got 3 test sessions in your job file, when they come through the orchestrator and then get passed through to the testers, the application scanner will see that there's 3 there and it will spin up 3 sets of Zap and Selenium. The reason for this is so that there's no cross-pollination between the different tests, so you can get complete isolation. Okay, so these emissaries here live outside of the application scanner, so they're separate containers, and they're hosted on Docker Compose UI for the local environment. In the cloud, they're just in ECS. So, yeah, and also once those tests have finished for each test run, then the app tester sends off a command to SAM CLI in the local environment, which runs the basically bring down the stage 2 containers, Lambda, and it brings these containers down. For the server scanner and TLS scanner, these emissaries live inside the actual tester containers. The server scanner is not yet implemented. The TLS scanner is fully functional. Yeah, and there's only one of these. There's only one test SSL emissary that needs to be spun up inside the TLS container. It's just another process because we only need to test one instance of whether your TLS is good or not, or basically the ciphers that are used and a whole bunch of other things in order to determine whether your TLS has defects or not. So that's sort of the architecture in a nutshell, I think. But how does PurpleTeam help us as developers? And how does PurpleTeam help us as a business that creates software? And why would I want PurpleTeam in my build pipelines? So to answer these questions, I'm going to take you back to a section that's in a number of my previous talks. Traditionally, how have we found security bugs in the software that we write? Basically, we haven't really, or we've done it really late. So our red team has a week or two to find all the defects we've been conscientiously adding for months, which costs approximately $20,000 per week. For a small to medium-sized web application, it's about 2 weeks. And the software project before release, the project itself is about 6 months for small to medium-sized project. So that's about $40,000 per 6 months per project. Generally, 5 criticals, 10 highs, 10 mediums, 10 low severity bugs will be found. And loads of bugs are left unfound, still waiting to be exploited. So the business decides to only fix the 5 criticals, because now each bug has an average cost of 15 plus times what it would have cost to find and fix if it was found and fixed when it was introduced. So that's 5 bugs times 15 times approximately 2 developer hours, and you've got $24,000 there. So the bottom line, for a 6-month engagement, you'll probably have a 2-week red teaming exercise, if you have one at all, and that'll cost you $40,000, and only 5 red team bugs are fixed at a cost of $24,000. So the bottom line is this is too expensive, it's too late, and there's too many bugs still left unfixed because it's now so late in the SDLC, and each bug now costs 15 times plus what it would have cost if it was found and fixed as it was introduced. So instead of deferring the finding and fixing of security defects to the traditional red teaming exercise, PurpleTeam helps us find and fix our defects as we're creating them. You might ask how. So PurpleTeam runs against our web apps and APIs as we're creating them, informing us of the security defects we're introducing in close to real time. PurpleTeam reports show us how to reproduce the attacks that found a given vulnerability, with tips on how not to introduce the same vulnerability again. And there's also techniques for removing false positives or any defects, basically, that you are not interested in seeing. So now we know we need PurpleTeam. Let's have a look at the local setup. Okay, so this is the docs for setting up the local environment. I'm just going to take you through the Docker network, system under test, Lambda Functions, S2 containers, and the Orchestrator. So you're going to want to set up a Docker network. These are the commands you do to do that. You'll need that in order to run it, because we've got the Docker network defined in the main compose file for the stage 1 containers. You'll obviously need to have your system under test up and running. That's the system that you're trying to attack and test. For us, we often use NodeGoat, which is another OWASP project for web applications. For APIs, currently we've basically just been using different customers' APIs to test against. But ideally, we want to have an API set up, or several APIs set up that we can use for testing. And that's actually one of the OWASP ideas for the Google Summer of Code for this year currently. So anyway, we use PurpleTeam infrastructure as code SUT. So this project's a Terraform project. It allows us to add in different systems under test and bring them up really quickly. So at the moment, we've got node code in there, and we can add pretty much anything else in there that we want, as long as it can be Dockerized. So yeah, you need your system under test up and running. If you don't currently have one and you're just taking PurpleTeam for a test drive, you can use node code. And we have an override, a Docker Compose override that you can apply as well. So everything should pretty much all work out of the box. Okay, so Lambda Functions. For your Lambda Functions, just head to the README there. There's really not much to do there. Stage 2 containers the same, head to the README. For the Orchestrator, you're going to, so this is the main a Docker Compose file that we use. Just hit that link and you'll see what it looks like. It's all in GitHub, everything's open source. So you'll want to set up some environment variables. You'll need to have some directories that exist. You define what they are, and you just need to set their permissions correctly as per the docs here. If you're running a firewall, you'll need to open up some ports. So there's details here on the firewall rules. You need to have host IP forwarding turned on. For the testers, as I mentioned, currently we've got implemented the application scanner, TLS scanner, service scanners stubbed out at the moment, waiting to be implemented. Which is also a job for someone else. It's actually also in the Google Summer of Code ideas list for students that are keen on having a crack at it. We've got 2 other testers that are currently implemented. It's basically a matter of following suit in most cases. Anyway, for setting these up, there's not much to them either. I'll just show you one of these READMEs. As you can see, there's really not much there. And they're all much the same for the TLS scanner because everything's just automated. So for the testers, testers, yeah. So I've been to the testers. For the CLI, you head to the README for the CLI. Now this is where there's a bit more work involved. Okay. So we've got 3 different types of ways you can install the tester. There's probably others, but these are the 3 that we've got documented. So you can clone a Git repository. Yeah, okay. So, yep. So you can clone the Git repository. You can npm install it locally, or you can npm install it globally. For the cloud setup, all you need to be concerned about is actually the CLI. There's no backend to set up. Everything else is done for you. Yeah, okay, so here's the install options again, and then you configure the CLI. So if you clone the Git repository option, this is a pretty good option if you're planning on running debugging PurpleTeam standalone with a user interface. The npm install option is a good option if you're planning on running or debugging PurpleTeam as a spawned Node.js subprocess, for example, from your Node.js build pipelines. So that would be headless. And the npm install globally is a good option if you're planning on running or debugging PurpleTeam from a build pipeline written in a different language. I can just show you one of these. So yeah, there's not much there. And into the configure section. Okay, so configure CLI. So basically, this is just some properties you need to set in the config file of the CLI. So there's a local config file and there's a cloud config. You can ignore the cloud config if you're not running in the cloud, and you just need to configure the local if you're running in the local environment and vice versa. And details here on if you want the CLI to be run in headless mode versus so that's headless, and this is with a character user interface there. Cool. If we're running the CLI, basically what we do is we take these same three options, put them down here, and then we just we've got details on how to run them for each of these three different options that you've installed them. It's pretty straightforward. So if you're using cloud, then it's job done. All you need to have set up is your CLI, and so your CLI installed, configured, and your job file set up and ready to run. I'll actually just show you docs for that. So the job file's in here. If you're hitting a browser application, the schema details are in here. If you're hitting an API application, the schema details are in here. Yes, if you're using local, then there's a bit more to know about running the back-end components. Okay, so it's, I don't need that anymore. So back-end components. So the docs for that, basically under the workflow. Yeah, so we've got emulating the AWS Lambda service locally. This is if you want to isolate your AWS Lambdas and debug them for any reason, like if I'm actually working on PurpleTeam to develop it. Otherwise, you're probably not going to need that. You may need some of the debugging stuff, and you're definitely going to need the full system run. So emulating the AWS Lambda service and all this stuff under here to there, I think, is around the Lambdas. Yeah, so these are actually the separate Lambda functions here and how you go about testing and debugging those. And then into the debugging section. So here we can debug everything in our back end. We can debug our Lambdas. Yeah, so that's the details there for doing that. I've got it's all set up in Visual Studio Code. So you can, if you're using Visual Studio Code, you can use these details here, and they should work pretty much flawlessly. For the app scanner and sub-processes, the details are here. So what happens is your application scanner spawns sub-processes. So the sub-processes are Cucumber. So the number of sub-processes that are spawned are based on the number of test sessions that are passed through in your job file. And you can step into each one of those if you want. And the details are there for that. For the other testers, it's even simpler because, okay, so so there's only one sub-process for each of the other testers. For the Orchestrator, there's no sub-processes at all, so super simple. For the front end, the debugging details are there. That's basically we just debug it in Chrome. But yeah, you can use anything. And you can debug the tests, details there, and the full system run. So all the steps are laid out here on how you actually go about running the whole shebang in your local environment. If you're running in the cloud, all you're concerned about is the CLI. So you really don't need to worry about any of this. It's just running it. From the CLI, all the details for that are in the README for the CLI, which we've already looked at. Cool. So I'm just going to take you a complete run through now of what a full system test looks like. So I'm just going to change the way I'm sharing my screen. rest of that.
Hi, today I'm going to show you a test run with the backend components as well. I'm starting Docker stats to show you which containers are coming and going. We start Docker Compose UI, which is responsible for taking orders from our Lambda functions to start and stop the stage 2 containers. We start SAM local, which is responsible for hosting our Lambda functions locally. And we already have our system under test running. Now once we've built our stage 1 images with npm run dc-build, we can bring them up with npm run dc-up, and then we start the CLI. In the bottom left terminal you can see the validated, filtered and sanitized job file contents. In the top right terminal, Docker stats is showing us the stage 2 containers being brought up. In the bottom left terminal we're checking and retrying that the stage 2 containers have come up and are responsive. All testers are now running. As the test run progresses, in the CLI tester complete panel, that's the donut meters, you will see the percentages progress. These are total percentages per tester. In the running statistics panel, just to the right of the donut meters, each row represents a test session as defined in the job file. Here I'm tailing the CLI TLS tester log just to save right arrowing on the CLI terminal to the TLS tester screen and not being able to also see the app tester progress. Back to the running statistics panel. The thresholds you see are also defined in the job file as alert thresholds. A given test session will be considered a fail if the bug count exceeds the alert threshold. Alert thresholds are useful for brownfields projects where you have existing defects but still want a test to pass. These are the definitions. You may find yourself referring to these quite often. Back to the running statistics panel. You'll notice a complete column. These cells represent percentage complete of the test session, where you may have more than one of these for a given tester. In order to initiate a test run, the build user needs to define and supply a job file. This is the documentation that will help explain the schema and help you construct your job file. Next, I'll show you some example job files. This job file is very similar to the one we're using for this test run, except we're targeting nodegoat.sut.purpleteam-labs.com, which is deployed using the PurpleTeam infrastructure as code system under test project. The new bugs panel of the CLI shows bugs over and above any specified alert thresholds. If this count is above 0, then you are going to have at least one failed test session. The total tester progress meter to the right of new bugs shows the combined progress of all testers. These logs I'm showing you are the raw CLI logs taken from the current finished test run. This particular log is from the low priv user test session of the current test run, currently being written to the top of the two CLI window panes as we speak. You'll notice that this particular test session is only testing a single route, the profile route of our system under test. This particular log is from the admin user test session of the current test run, currently being written to the bottom of the two CLI window panes as we speak. This test session is testing two of our system under test routes, the profile route followed by the memos route. As you can see, the server tester is currently inactive. Now we're looking at the TLS tester log. There is only ever one of these per test run. You'll notice the color codes in amongst the text. These are used to display the log text in color. We'll see how this works soon. We're looking at the same CLI logs as before. Tools such as cat, less and tail, if configured correctly, will render the color codes. Just reiterating that these CLI logs are currently being written. I've just taken them from the finished test run. This is the low priv user test session CLI log from the application tester. As you can see, this is a failed test session. This is the one and only TLS scanner test session CLI log that I showed you before, but with the color codes rendered. These CLI logs are what is printed to the CLI terminal if you are running it in CUI mode versus no UI mode. Right arrowing and left arrowing in the CLI terminal will switch between the different tester windows. As you can see, this is a failed test session. When you see the outcomes have been downloaded to message, that means the test run is complete and you can now inspect the report files generated by the emissaries and the result files generated by Cucumber. This is what the outcomes archive looks like once it's been packed by the orchestrator and sent to the CLI. You'll notice the report and result files. This is the HTML report file generated by the application emissary, Zap Proxy, for the low priv user app scanner test session. It lists the alerts or defects, along with how they were found, how you can reproduce them, as well as directions for fixing them. This is the HTML report file generated by the application emissary for the admin user app scanner test session. This is the HTML report file generated by the TLS emissary, testssl.sh, for the one and only TLS scanner test session. This is the markdown report file generated by the application emissary for the low priv user app scanner test session. This is the markdown report file generated by the application emissary for the admin user app scanner test session. This is the CSV report file generated by the TLS emissary for the one and only TLS scanner test session. Here I'm highlighting the severity levels. These can be one of low, medium, high or critical. Refer to the job file documentation for further details on these. This is the JSON report file generated by the TLS emissary for the one and only TLS scanner test session. These are the three ND-JSON result files generated by Cucumber for the 3 test sessions. Low-Priv user app scanner test session, admin user app scanner test session, and the one and only TLS scanner test session. The app scanner admin user test session for the profile route has completed. It's now starting on the memos route. The app scanner low-priv user test session for the single profile route has finished. The log, which has just scrolled off the screen, provides defect counts and details of where to look in the reports. This is the log and outcomes files documentation. The app scanner admin user test session for the memos route has completed, which means the test session it's in is finished. In this case, both low-priv user and admin user test sessions have failed. The CLI log file that I showed earlier contains details of how to use the report files to locate and remediate the defects. You'll also notice that the stage 2 containers have been brought down. Now we've just right arrowed to the TLS tester to watch it finish. The test session for the TLS scanner has now finished. This also failed because the defect count exceeded the alert threshold that the build user defined in the job file. You may also notice that the total tester progress meter hasn't reached 100%. This is because the server scanner isn't currently enabled. As you can see, the outcomes files have been downloaded for you to inspect.
Alrighty. Alrighty, so that was a full system run through. So we're looking for contributors to come and join the OWASP PurpleTeam core team as well. If you're interested, contact us. This is our Twitter handle, and these are all the ways you can contact us. So you can open up a GitHub discussion. There's the OWASP PurpleTeam Slack channel. You can get an invite here and then jump in. So yeah, that's the invite to the actual OWASP Slack, and then you can jump into the Project PurpleTeam channel and hit us up there. There's a contact form and email address there. You can DM us on Twitter, lots of different ways. If you want to get involved in actually contributing, there's a contributing guide here, and all the source code is in a GitHub here. And yeah, that's pretty much it. It'd be good to have you helping us out, or taking PurpleTeam for a spin to improve the security in your web applications and APIs. Thanks.
Cool. Really nice. And I'm not sure if Steve has any questions here. Any guys have any further questions? If not, I think we call it a night or a day. This is the beginning of your day for you. Right, it's the end of the night. But well, really good, man. Oh, thanks for doing this session.
Yeah, no worries. Thanks for having me, Dennis.